Hello, everyone.
Hello, everyone. Hello, Cedric. Hello from Germany, Kaiserslautern. Hello to Paris. And are you in Paris
Yes,
now?
thanks.
Okay.
Yes, I'm close to Paris.
Yeah, and hello
Yeah.
to everyone, every country, and every city, every place you are watching us. I know there is a very long list of countries of people who joined us today. If you see us, if you hear us, please set thumbs up in YouTube chat or whatever you are prefer. Say hello, and we will know what we are good to go.
Oh,
Hey,
based on comment on the chat, I can say that they can hear
yeah,
us for sure.
definitely. Okay. And I don't want to wait for too long before we proceed. Oh, Brazilian fellow here. Perfect. What's the weather in
Great.
Brazil now? I'm very curious. Oi, galera.
It's pretty early in Brazil.
Yeah.
8 a.m. Depending on where you are. Brazil is so
Yeah,
big.
definitely. Okay. So, we are good to go, and just in the beginning, just 2 words about the things what going on right now. So that's, if you are new here, that's DataStax Monday Learning, our way to make your Monday great and make you better developer and learn something new what you may need in the development world. And that's every week, every Monday. Best instructors, well, someone has to say that, I guess. With most important topics from engineers to engineers. And today that's Alex Volochnev and Cedric Lundven, and we speak about Docker things. So, as you maybe know, I hope, that's the Docker containers course. But this day it's even better. This time it's even better because we announced what we have to extend this course, and now it's 5 weeks, not 4 weeks as we planned before. As due to high demand, we added introduction to Kubernetes course. That
Great.
was really a highly asked question, like please do Kubernetes. From another point of view, Kubernetes is not the thing what developers I usually do, but more about thinking DevOps or in general operations. But and this course was designed for developers. But if you ask it so much, of course we will do it. We use Kubernetes heavily, so we have some words about that to say. But that's not for today. That's going to be on 26th of October. That's kind of standalone session. So call your friends who are into Docker already, but not into Kubernetes. It will be the same 90 to 120 minute session, and we will play a lot with Kubernetes for real. So that's like will be a very practical workshop. And today, I need to get back to the screen. We speak about application development with Docker. But before that, once again, like I did last week, for this course, we got over 1,000 registrations and over 5K views on YouTube for the videos together. And overall, it's almost 2,000 already hours of overall watch time. And that's like really, really a lot. You trust us something even more important than money. You trust our time, and time is what's the priceless thing, absolutely. So thank you so much for watching us. You are great, and there is one big thank you. So let's move on. It's a very good time to start. Week 3, application development with Docker. And actually, why I wanted to do this session about application development with Docker. You can learn basic Docker concepts pretty easily, but then in many companies I've seen many times people using it in really weird ways, and they're trying to work with Docker, Dockerized infrastructure and environment like we used it to do before, and that's not the correct approach. And well, that's pretty easy when you are trying to handle a bot like you would handle a train, I don't know. So this week is about how do you develop application with Dockers, how to avoid most common mistakes, and so on and so forth. And first thing I want to start is to really simplify your development, simplify your deployment. The final goal, it should be a question of minutes to run your application on a new machine. Like I told you some last week on one of my former projects, the story to set up a new laptop for developer, it was around 2 days. So every new person joins, he or she simply wastes few minutes, not few minutes, but 2 days, yeah, hours and many working hours just to set the things up, not to start develop application, but to at least make it running on the laptop. In the end, with Dockerized environment, it was within 15 minutes needed to download Docker images. An application was running already from 2 days to some minutes, and that's what you have to reach at the very first starting Docker transformation. What's the most important? Simple, reproducible environment is very important for successful development. You will need that both for development environment, but also for staging, testing environment, and well, production is mostly probably going to be a bit different. And seriously, there should be 2 commands to run your application on a new machine as long as you have Docker installed. Git clone project, Docker compose app, and you should have it running already. If your setup includes like 5, 6, 7, 8 steps, then, well, or you have very special use case, or you are doing something wrong. I would fight for those 2 commands, maybe 3, 4, but not complex than that. Even for really complex infrastructures, it should work like this.
Yes. Small ads, please.
Oh, thank you. Yeah, here we go.
Let's see. Magical boom.
Yeah.
We are.
Good. So, also, it should be very easy to switch from production mode to development, well, not production mode, but just running mode to development mode. I will show you in a moment. But there is one thing we have to discuss before. I hope some of you know the difference between monorepo and polyrepo. What's the point? Some companies, some teams working on the monolithic applications, and they have one big Git repository storing everything they need, front end, back end, all the things together. And that's traditionally call it monorepository. So your team works with a single repository, or maybe some of them, but we speak about the main project. Polyrepository is the often thing when you work with service-oriented architecture. So if you see this example on the right, speaking of monorepo, that's kind of 2 exactly the same applications by the structure. So some services, some libraries, web part, mobile part. We can even say that's the same exact application. But in first case, we are going to have like 8 on this example Git repositories handling different parts. And with monorepo, we have one single application, one single Git repo handling all the parts. And when people started to use microservices, at first they started to use polyrepo very actively. And at some point, they found out that it's maybe not the perfect approach. The problem of a polyrepo, when you work with a simple repository and you do the changes in multiple services, those depend on each other. It's going to be what's a Git about? It's about managing change sets. And if you have multiple repositories of the code which is technically connected because those services are collaborating, but not connected in your Git because you are using polyrepo, then there is no way to manage a single change set if you are touching 2 services to communicate with each other in a new way. And it will be 2 change sets, and that may bring some big problems, and it brings problems pretty often. So, despite how polyrepo looks good to them microservices, more and more companies start to think monorepo. So, despite we have different services, they will be in a single Git repository and handled together. It brings some new problems, it brings some it solves some old problems, but the main idea, you can change them together and you can keep full control over your change sets. Now, what is good? As always, there is no simple answer because you have to decide for your situation and your use case. But the general idea is what if you are working with monorepository, it's going for you to be very easy to add Docker Compose YAML, or maybe some of them for different situations we will cover in the end of this workshop. And what you are going to do with the case when you are using polyrepo. In this case, mostly probably you are going to add, you are going on or to set one of these repositories as main and describe your ecosystem and describe your application in full with Docker Compose YAML in these repository, or as some companies do, oh my god. Yeah, Deutsch und Russisch. And just create a dedicated repository where you handle description of your system and you have Docker Compose YAML there. For example, for our distributed microservice-oriented architecture killer video, we use all-in-one. All-in-one is I will show you later. It's just a repo storing some Docker Compose YAML files for all the cases of us using this application. Now, next point, and I want, is there any interesting questions in chat?
No remark, jokes, everything's fine.
Good. So let's move on then, and we have next point, source code. So we can easily write a Docker Compose YAML file which will use images, and we will have those images running. It's not so hard. I hope some of you did that already. And when we have to put our changing code somehow where not on the build time, but on the development time, and that's like a continuous changing process. You write your code, you change it over time, and you don't want to build your image every time because it obviously may take a lot of time. By the way, if your Docker build takes too much time, you must attend our next section. Next week, we will speak about optimization. But still, so we want to put code from our local machine to the container, running container, without the need to restart it every time, or at least without the need to rebuild it every time, rebuild image, because it may take some time. And well, I don't want to wait for Docker. I want Docker to improve my process, not to slow it down. Like we discussed it last week, best way for us to put our code and sync it with the running container is a bind mount. That's the simplest way when you specify you want to use this folder to this application. And then putting any changes to your local files with your integrated development environment or whatever you use, Notepad, hope not. You simply put all the changes to a container. And there are two use cases we cover in the next steps. Some languages are interpreted like Python, and some languages are compilable like Java. So workflow is going to be a bit different today. But again, now principle changes, especially if you want to build in container, like I will show. We have here a part of our Docker Compose file from Killer Video Reference application. We used to show how we work with Cassandra and DataStax Enterprise. We have here a line which was uncommented because I was intended to just run the application and I was using image. And let me switch to a pointer. Yep, and easiest way for me to switch to local build instead of image is to comment out image and use build, specifying the folder where my source code is, and specifying volumes I'm going to mount and where I'm going to mount them specifically. And there are two main approaches. One is what you have this main Docker Compose YAML file, which describes all the system, and then you have these fields here to comment out image and uncomment, build, and volumes. So you will have everything mounted directly to the running container. So your source code will be delivered. And another approach, especially for polyrepo, when you have dedicated Docker Compose YAML file per application you are working with. And which way to go? That's again for you to decide. We are supporting both for killer video. So if I would show how it looks like that, for example, what was the application, I will make it a little bit bigger, so you will see what's going on.
Yeah, maybe you can show where is all these killer video
you are right.
files.
I will better show it on GitHub. You are right. So let me stop it, and because I can show it locally, but when you will not know where to watch.
Yes, and all those files are available for you. So it's a full-fledged application with Cassandra, so distributed database, application with backend in multiple languages, front-end, and also some data collecting from YouTube to the database. So that's really a distributed full-fledged application, and that's a pretty good sample to have a complex Docker Compose. And there, by the way, Alex also put all the Kubernetes.
Yeah, I did. Guilty, Your Honor. Good. So that's github.com killer video. It's our reference application how we work with Apache Cassandra and DataStax Enterprise. But that's not the point of today's session, because we don't speak about the databases so much. And we have some repositories here in killer video. And the one I was talking about today is the killer video all-in-one. This repository is a collection of Docker Compose YAML files. By the way, we cleaned them up, so only 2 left, and I even don't know the difference between all-in-one and just Docker Compose, because this one should be Docker Compose all-in-one. We will see.
I think one is everything except the code you are running locally, like the backend. And the other is everything is in Docker already.
Yeah, good. And let me see. Okay, so those are Docker Compose files we are using to run killer video. So git clone Docker Compose up, and you have killer video running. And okay, there will be one change. You have to generate your own YouTube API key, because we don't share ours, of course. And we speak a lot about the secrets a little bit later. And second part here is the Kubernetes part, but we will speak about that 2 weeks later. So, as you see, in this case, we have Docker Compose with all the files explained. And this one is the main Docker Compose for us. We use all the time. But in some cases, you want to use, you want to have specific Docker Compose YAML files per repository. So, for example, let me find this one. For one of the applications, I'm trying to remember which one was it. It was, I believe, generator, but well, it was for all of them. We have this Docker Compose YAML file, which is specific. And if you work with this part of the application, it may be more convenient for you to have multiple Docker Compose files with different configurations. If we watch this Docker Compose, it will be different, because it's a project specific, specifically for the killer video generator service. We have it set up differently. So it's from the beginning set up to be for development purposes, not just to run or execute tests, but to build it. It exposes also port for debugger. We cover in next slides, because, well, debug is very important. And that's a per project specific Docker Compose YAML file. Benefit of this approach, I'm going to develop generator. I know what I'm not going to touch other services. I do git clone, killer video generator, Docker Compose up, and I have everything prepare it for me to develop it already. I don't have to do any additional steps to uncomment some lines, change some lines, and so on and so forth. And that's good. From another point of view, now you have one more Docker Compose YAML file. And if anything changes and you have to add a new service, or you need to change environment variable for some secondary service, which is reused here, like let's say we are using here DSE config, doesn't matter what is it for you, doesn't matter. That's about microservices, so that's like isolation. Don't think too much about the services you are not developing, just utilize them. So if I have to change something here, then I have to go and change it in the Docker Compose file of every repository we have. And how many of repositories we have? Like last time I needed to change around 7 repositories due to one change in the main Docker Compose file. And that was like definitely not convenient to do. But the benefits is higher. So that's for you to decide what you want to have. Good. Hey, good. Okay, so using volumes, using bind mounts as you did last week, you know, very easy to put our code into the application because it's bind mounted. Any file I change locally, it will be also changed in the container. But then there is one very important thing to consider, and that's environment-specific data. Take a look at the thing. That's the copy of this Docker Compose file I've just shown to you, and we set an environment variable, killer video YouTube API key, set your YouTube key here. Why we don't have a YouTube API key here? Because, well, we are using YouTube API pretty heavily, and YouTube is going to bill us and get some money from us if we will overdo that. And we don't publish our own YouTube API key because, well, some people may misuse that, and we will be paying for that. So all the keys, all the passwords don't belong to this thing. But then this approach, is it so good or is it not so good? I would say no. Why? Okay, as long as you are the one and only developer working with the code and you know you shouldn't git commit and git push your YouTube API change, API key, it's not going to be convenient for you to work with this approach, because if you did some changes for the Docker Compose file and you want to push them, you first have to remove your API key, git commit, git push, then return your YouTube API key because you are going, or password, because you are going to need that anyway. And of course, that's not the best approach. So we have something to improve that. But that's what really important. Do not keep any kind of a sensitive data in source code. In general, that's not even about Docker, but it's always API keys, passwords, any sensitive things you don't want to open. Never have them in Docker. Keep them environment specific. For example, my production application works with my production database. And my production database key password is stored in the environment variables of a production server, and no one has access to that except of some operations people, and well, not all of them, of course. And therefore, this key is under control, and I inject this key using environment. But if I inject this key, I want to kind of have a control over that. So I don't want to have it open in the Docker Compose YAML, but I also don't want it to be somehow unavailable or, I don't know, hard-coded in the application. How do I do that? So there is a very nice approach which helps a lot, especially if you have multiple services using the same environment variables. For example, you have 5 services working with the same database and using, let's say, the same password. And in this case, take a look at the big change happened on my services definition on the Docker Compose YAML file on the right. Env File replaced environment variables definition. And now, instead of defining those variables in my environment variable in the Docker Compose and copy pasting them for every service reusing these variables.
Wow.
Yeah, and in some cases, like at one of my projects, our services list was, I don't know, around 30 or 35 different services defined, and most of them reused a lot of settings, so it was all the time copy paste before we introduced Env File change. And we have this def Env File included, and that's a just standalone file. Notice, do not just copy paste environment variables there. Instead of that, you have to, it has to look like this file with env variables more in Linux style, so no YAML thing, blah blah blah, double point space value, but instead of that, key equal sign value. And then finally, what you have to do is to put this file to gitignore, and that's absolute must-have, because if you don't have it in gitignore, at some point it will be inevitably published. So trust no one, don't trust your colleagues, don't trust yourself, and keep these things under gitignore, so we will never get to Git in general. But what's recommended in this case, because in some cases this def env file may be huge, you may have a template. So you may have something like def.env.default, where you will have default settings for the project with no real data, specifying put your personal key here, put your personal password here, and then, as we discussed in the beginning, running of your project will be out of 3 steps. So git clone, copy and change this file to your specific settings, Docker Compose up. And with this env file directive, you include it to every service which has to use the same values. And that's a very cool thing and very convenient approach to use. There is one more improvement which may help you depending on your situation. There is a default environment file. If in your project, in the root folder of your project, you have file.env, so the short name of the environment, environment variables from that file will be loaded automatically, so you don't have to define them at all. But that's like convention over configuration. It's a little bit not obvious, and for some developer who doesn't know about this file, he or she may run into big troubles, because like it works this way and I have no idea why it happens. So convention over configuration approach may be convenient in some cases, but it's also a little bit of dark magic. So personally, I prefer to avoid these and have more explicit definitions. That's where we take these file things. Where do we take these definitions?
I do the same. Even in Java development, I tend to do configuration, explicit configuration, just to avoid any magic things happening. That's just me.
Yep. In general, that's a holy war question, because some people prefer convention over configuration, and they're also right in some cases. But, well, it's a special story. And finally, that's not enough to provide environment variables. It would be great, but still there is a work to do. And your own application should support those environment variables as well. You remember, like at the first class, at the second class of this series, we did some things with MySQL or Nginx and so on. And we set some settings like MySQL root password using environment variable to be like this. Set my MySQL root password to be 12345. Very bad idea in general, but still. So there is no magic. Of course, the application should support this environment variable. And there is a special script inside MySQL container which handles those environment variables. And so do you. That's on top we have a Python example, on bottom we have Java example. Doesn't matter which language you use, all of them provide enough tools to work with operating system environment variables. So in some cases that's going to be simple, like with Python os.getEnv, and we specify which particular values we are going to use, which particular keys and environment variables. And with Java, it's mostly the same, system.getEnv, and specify value you're going to use, or you can load all of them if you need with system.getEnv without any specifications. Convenient usage of environment variables, that's a long story, because in different frameworks with different libraries, you may have to feel this differently. So if we would try to cover that for every mainstream framework and every mainstream language, it would take ages. And I think what I want you to understand here is the general idea. You inject environment variables in your containers, and your containers must handle them. Very simply, in the first example, we are going to connect to Killer Video DataStax Enterprise database, and we are using therefore username, password, contact points, and service ports defined in those environment variables. And by the way, notice first two lines are different to last lines. In the first case, we are require from person to provide those environment variables, and there are no default values, so it will not work if you give us nothing. But in this case, third line and fourth line, they have default values, because for we know the typical situation we run as application, that's Docker composed staging environment, let's say. And we know what the default container name will be, DSE, default database name we are going to contact. That's why we provide this default name. And the same for the port, service port will be, for our case, 50101, and we use default value. So the idea is there's a thing called a developer experience. Very underestimated thing. It's like user experience, make your product convenient for users. And that's a great idea, but that's not enough. Developer experience is about to make your system convenient to develop. So make your system convenient to develop itself, and make setup, prepare it as much as possible. In this case, batteries are included but swappable. I set default port 50101, but if in some case one of my colleagues need to change it due to some reasons, he or she may easily do that, just setting this environment variable, and that's very easy. Good. Then, build and run. So, that's important to understand, but build and run are two different steps, and you have to consider them separately. For example, Java applications build requires a lot of build time dependencies. Those are not required on runtime. And therefore, if you do just everything in one simple Docker run, Docker build, it may be a serious overkill, and your final Docker image is going to be like 1.5 gigabytes. And that's what you really want to avoid. So there are multiple different approaches, and people do it different way. My point here is for compilable applications, you may do build and run very separately, and have at first build just to generate the deliverable, like Java jar file or Golang compiled file, and then just run this file in the image, which is different and which has only not build time dependencies, but only runtime dependencies. Usually this list is much smaller, and they are much smaller as well. And we have to focus on these to deliver properly developed applications. I will show you a couple of examples here. Let me find the thing. Okay, then. Good. No debug. Still yet build and run. And we have here a killer video. So let's take a look on the Docker file for this generator service. So that's a pretty old one. So it uses Node.js version 6, which is obviously way too low, way too old, but works very good for us. And there are some important things we want to do. First of all, those times Node.js used root user to do all the job, and we don't want to do it. We don't want to run all our processes under root user because it's going to be too much. So first we are adding killer video user and killer video group to run all the operations with this user. When we set default environment variable for Node.js application to be production. I guess some of you are not so familiar with Node.js and JavaScript. That's perfectly fine. That's still good as an example. I believe everyone understands what's the environment production or environment development. So we are going to have here some dependencies. We are going to prepare here some folders we will work with and set it as a working directory. Good. We copy required files here at first, so those are files explaining our dependencies, what's required to install the dependencies. And then there is a very long command, which is pretty interesting technique. We will explain it in bigger details next week, but in general, what we need to know. First, every step is one more layer or many more layers. And every step is executed on build time of a Docker build in a container. So we use containers to build containers internally. Okay, and if you do at first apt-get update, run apt-get update, when you do run apt-get install, and then you do run apt-get remove and wipe out dependencies. What it will lead to? Every step will be executed in a separate container, and change set will be committed in the end. So if you first make apt-get update, then in second run you remove some files. As a result, you will have change set plus, adding some files, when change set minus, removing some files, and your Docker image will still be big in the end. That's why we do all those run operations as in a single run statement, because in the end of the run command, Docker will commit this Docker image like you commit code with Git, but it will be clean already. So Docker commit will happen only in the very end. And that's why first we update our things, we install dependencies, we do npm install. As you see, we need to have pretty lot of things to do our npm install and npm build here. And then we remove these dependencies and wipe out all the apt lists we need to install that. It looks overcomplicated, but generator has some heavy dependencies. So that's why it's a pretty long process. And finally, we have it done, and after Docker finishes this run directive, we will have npm install executed, but we will have no Python, we will have no make, we will have no G++ like they never existed. When we copy application itself, we define environment variables, and that's an interesting thing. Arc statement, we never discussed it before. Arc statement allows you to be environment variables injected on build time, so I can specify this environment to be injected on build time. It's not necessarily, but it can be done. So in some cases, I want my image to be fully prepared with API key included into that.
Yep. So how do you define an arc then? It's not -e or anything like that. How do you provide this var to
that's
the build?
done on Docker build. Docker build. I have to remember the directive. So
Docker build dash
yes,
maybe something like that.
So the point is that's to inject environment variables not on runtime, because on runtime we do on build time. That's a principal difference. And thank you. That's a good question, by the way. So on runtime, we inject environment variables we know how, with Docker Compose YAML environment, or with Docker Compose and file, or with -e. That's pretty clear. But arg directive allows you to include some environment variables on runtime. Three main cases I was using these in the past. First one you see here, in some cases we want our images to be easy and to simplify usage of application, so API key is included into that and on build time, and that makes things easier.
Oh, so I do have the answer if you want, because I charge in the same way.
Please.
And we are still on the topic. So you are doing docker build --build -arg, and then key equals value.
Yeah, thank you.
So it's really --build -arg. So let me copy paste that in the chat. Boom. Okay.
Yep, and I see a question regarding slides. Don't worry, slides to be added directly after when
I can do it in the meantime if you wish. And also I do have a question on hold when you finish this section.
Okay, thank you so much. Yes, so yes, we can add slides right now or directly after the workshop. So that's fine. And yeah, I'm almost done here. So, and finally, as it's done, all those steps were done with root user. So the Linux administrative user, which has all the permissions to do apt-get update, apt-get install, and so on. But we don't want to use this user anymore, because now we just run application and we don't need root privileges. So we set user to be killer video, the one we created in the beginning, hope you remember. And finally, we specify the command which we are going to execute, then container starts. By the way, this command better to have not in the end of a file, but in the beginning of a file. But why, I will explain next week. I want you to keep going.
What a teasing.
Yeah, some teasing.
You need to come back next week now.
So what was the question, Cedric?
Oh, the question was about the Docker volume.yaml files. So, I mean, no, Docker compose.yaml files. Would you consider try to handle all the service in the single file, or split into multiple files? And if you split, how do you decide, on which file do you put your services?
Very good question, and I know what you mean. There were some heavy discussions in some companies I was working and some projects I was working. My personal approach is just noticed it a few minutes ago, developer experience. Keep your system convenient not only to use but also to develop. And if I'm having multiple Docker Compose YAML files and I have to combine some of them into a system, then I have to go with Docker Compose up my -f this file, -f that file, -f third file, and in the end that's a very long line and very error prone from my point of view. And personally, I prefer to have like 2-3 Docker YAML files, including everything what we need to be executed completely standalone, and I can go with simply Docker Compose up, and I have my applications running using default Docker Compose YAML. But also I have Docker Compose CI, Docker Compose.ci .yaml we will cover in next slides for continuous integration, which is a bit different because for testing I don't need some of the services, for example, and then setup is a bit different. Obviously, this approach has a downside. You are going to have multiple Docker files, and if you change something in one of them, you are going to change something in the second one. For me, it's perfectly fine because usually amount is not so big, but the usability of the system in the end has higher value than the problem delivered by this duplication. So that's kind of a question of normalization and denormalization. In some cases, we have to go with normalization. In some cases, we have to denormalize. And that's exactly the same situation. So...
Oh, okay. I would agree, even if it means duplicated the service in a way, because sometimes it's in the file -ci, it's in the file -dev and you duplicate the service, well, in the end, you may use different version of the service, not using the same environment variables. So even if there is a little bit of duplication, having everything in a single file per use case, to me, it's what I feel the more useful.
Yep, exactly. But again, there is no simple answer. So your case, your story may be different than mine, and you will end up using exactly opposite approach. And that's perfectly fine. I'm trying to find Docker Compose CI. I will need it any moment anyway. Oh yeah, here we go. That's Docker Compose CI.yaml for Killer Video Java backend. And I'm trying to remember what was the principal difference of that to use. First, we are using locally built image because it's executed on the continuous integration server. And to test Java, we don't need web, we don't need generator, we don't need others. We just have Java per se built on the build server. We still need database because it's an integration test, so we need database to run it. And we need DC config to set up this database. So for example, when I run tests for the Killer Video Java, I have only 3 services running. And my continuous integration server is very thankful to me because I don't make it run the full set. And full set will look like, let me switch back with just Docker Compose. It will be there for web interface. It will be, well, Killer Video Java as it is. We are going to use DataStax Studio to work with the database data. It has still the same database, and it has DC config like before, but it also uses generator. So it's much more heavyweight setup. And take a look. You may say when you have multiple Docker Compose YAML files, if you have to change something in all of them and you miss one, and if you have many of them, it will happen one day. It's very fine. In general, that's the approach to the development. Fail fast. If you design how your development workflow works, if you design it to fail fast, and if you design not to deploy to production things what's broken and have a proper continuous integration and delivery process, then I'm okay to fail. So I forgot to update this file. I run it on staging. It's not updated, so it doesn't work. Tests red, everything failed. Okay. I investigate that, I put the changes, I'm like, oh, I forgot to do it. That's shame on me, but no one ever noticed that. And
speaking of error and everything, so I know you don't and I don't either, but do you know any web UI working with Docker?
Web UI working with Docker? So sure, we have this Docker desktop.
In Docker Desktop, you do have the dashboard, true?
I think so.
Looking on the internet, and also I heard about somebody quoting portainer.io, but we are kind of terminal guys, so
yeah.
Why a UI when you can do a grep?
I can tell you just an incredible story about the best user interface, graphical user interface for Docker I've ever seen. It was just incredible. Very many years ago, I was at the DockerCon in Barcelona, Spain. And I was just an attendee those times. And it was very interesting story. Some people, I forgot what was the company. I think it was a Docker core team. They implemented a Docker graphical user interface using Minecraft. Seriously. So you have a special racks, let's say, with images, and you start with Minecraft, join special server, which is connected therefore to Docker server, and you go to these servers, you go to these racks, take an image, like real object in Minecraft, take this image, go to a special rack, and set it there, and it's considered like Docker run. And if you want to stop it, you grab this thing, remove it, and Docker stops the running container. It was just incredible. I think you can find the demo. All the room, and it was a huge room, was laughing so hard. That was just incredible. Yep. So there are some graphical user interfaces. I'm sorry I cannot help you with that, and Cedric as well, because, well, yes, as said, we are console guys. I know what this Docker desktop provides some overview, but now I even not able to find it. How I did, I reached it somehow before. Dashboard, here we go, dashboard. So you can see running containers with dashboard. I hope it's starting. Oh, okay, it's starting.
So it's called Dockercraft.
Yeah.
Using Docker with Minecraft.
Yes, yes. That's just incredible. Maybe you can send the link to.
I did.
Oh, you did. Oh, thank you so much, Cedric. It's always a big pleasure to work with you. Great. So we can have some containers and we can start them, but well, that's not my thing, definitely. Old good console. Yeah. Good. Okay. So and speaking of build, therefore for Java things, in this case, where is my Docker file? This Docker file is, as you see, looks much smaller, and it's a great file because it illustrates the thing I wanted to show you. First, it uses OpenJDK official container, which is great. It has maintainers specified, which is also good, although maintainer instruction is now deprecated. So we have to clean it up. It also sets entry point for us to know which command with container will be executed in the beginning and set some Java security things. Maybe Cedric would explain us in the next Monday learning things. And it uses killer video java.jar, and it exposes port 50101 as the default port for our services. And finally, we copy this file into the image. And that's at the same time great and not so great. What's the point? In this case, this Docker file is not self-sufficient. You will see many self-sufficient Docker files and not self-sufficient Docker files. What's the difference? With self-sufficient, like we've seen before, I say Docker build, it will build. In the end, I can run the application. I don't have to do any additional steps because npm install was executed on build time and dependencies were included on build time. And in this case, if I simply do Docker build on this Docker file, it will fail. Why? Because jar is not compiled yet. And therefore, Docker build here consists of two steps. First, you have to build this Docker. First, you have to build this killer video Java jar. And second, you have to run Docker file. And that's fine. But it must be documented. I mean, in our case, that's documented. But if you do not self-sufficient Docker files, I don't like this style so much. And in second point, to do this approach, you will need to have Java installed on your machine in order to build that. So another approach would be to have another Docker file, like dockerfile.build, for example, which will have all the required Java, Maven, and other things. And when you have to build it, with this Docker file, you can say like Docker build, specify this file to use for build, and you don't need Java and all the things installed and so on. It's still in the container, but in the first container to produce jar, and then finally you use this jar in a tiny, great, nice Docker file like this. And Java developers would say, why would I not have Java on my local machine? As long as you start to work with big distributed applications of many components, like I do if I would install all the dependencies, all the languages in different versions I would need in multiple projects, my poor MacBook would explode in some months. So I prefer to keep all the dependencies in multiple, in Docker things. Those are very easy to get rid of. Docker, image, remove, boom, all the dependencies are wiped out. And that's what I like. If you work all the time with the same project, it also makes sense to have your dependencies installed locally. So both approaches may be fine for you, but you have to know both. Have dependencies in Docker, have dependencies locally. I prefer to have dependencies in Docker, but I have very many projects on different languages with different dependencies and so on.
Yeah, and the entry point is probably as well deprecated.
Anyway. Really? Entry point is...
No, not the entry point, but you know, the way to override the java.security.egd. You know, the stuff I should explain in a couple of weeks. It might be deprecated. And also, you should not use uuid.random uuid anymore. It's a blocking call and access the disk. And now in the Java world, it's more and more everything is reactive. We will talk reactive on next Wednesday.
Great. Cool. So now, and one last thing. Maybe the most important thing. I've seen so many times people doing using very weird approach, trying to run Docker. They run the process, they developing, like I'm developing Python application, let's say, and I run it locally as a normal process in my laptop. And all the dependencies like database, some backend services, some whatever, I run as a Docker containers. It brings me inevitably into a very complex network situation, because I have to pass through local network calls to a container and pass through container calls to local network. And it looks always very ugly because there are some complicated setup and so on and so forth. That's actually not required at all, because when you work with Docker, easiest approach is to run everything in Docker and to run your own application you are developing in Docker as well, so they are in the single network and they can communicate directly. Some people then told me how I'm going to debug. I will be not able to debug then. And that's very wrong, because debug is still very easy with Docker. So, simple story. Debug containerized.
What this slide? What this slide? No way.
Yeah. Have you seen O'Reilly books? What are they using on the front page? Like
Bugs.
Some very weird things. So this one at least relates to bug. Okay, so debug containerized application is different, but not hard at all. If you know something about the debug, and that's important. And we just need a couple of extra steps, very simple steps. So if you run your application in Docker, you don't have to drop debug. No, we all have to debug, and that's a very important step. But also you don't have to run your application locally in order to be able to debug that. It's simple. So first we will need a debug port to connect. For example, if you run a Python application, or if you run a Node.js application, if you run Java application, you're usually going to use one port as the main port. It accepts connections, like port 80 if it's a web application, let's say. And also, you're going to expose one more port to be available for a debugger connection. This port is different for different languages. We will see a couple of examples. Next, we need service to run with debug enabled, and for compilable languages, we need a service to be built with debug enabled. And we need, finally, a remote debugger session. Let's get closer to practice. Speaking of Java, we need to build the service in the debug mode first. And I'm not so much a Java guy, so Cedric may say a word on that a bit better than I do. We have to expose debug port, like for example here on the picture on the right we are using port 5005, and but it's, well, actually maybe different. I have no idea what's the default debug port for Java.
I'm not sure that is the default port.
Yeah, so it doesn't matter. Just important what left part will match the right part, let's say. So debugger will be able to connect.
Just you set the value.
Yep. We start the service in the debug mode with a custom command, like what we are going to have. Transport DT socket, server yes, suspend no, address specification, and so on and so forth. And debugger is an attached to remote Java virtual machine mode, and that's it. And you run remote debugging session and you debug it exactly like you usually do. With Python it works even easier because you don't have to build application in the debug mode, but practical example is exactly the same. You you have to expose port, and you have to start service in the debug mode, and then attach your IDE based debugger usually to this port, and you have all the fields. The same way works for Node.js application, but also you may have not only a debugger there on that, but also watch. So your files will be recompiled, well, not recompiled, but transpiled or whatever you need to deliver changes immediately. So all the nice options like file watch and automated file updates works perfectly with Docker, and you don't have to run Docker locally, and that's important. You don't have to run application locally trying to work with services in Docker. That's weird and I would say even awkward way. And my favorite topic here, and a source of really a lot of mistakes and bad situations using Docker, are the people trying to build Docker images locally and push them to a registry manually. The problem is local build is a local environment. Your development environment always affects your build. And there can be some changes what you can build your image on your own, push it to the registry, when on production pull it and have it running successfully. It may happen, but also there may be some extra files, some not required things, some possible mistakes, some secrets exposed, debug mode enabled, and so on and so forth. So what we really suggest to do always and absolutely always is to have automated build. And what does that mean and how it works? Answer in general is very simple. There are enough of continuous integration servers, build servers, open source, proprietary, publicly available, on premises, whatever you want to have. Like most widely used one is Jenkins, but there are also Travis CI, now GitHub Actions, which is a new guy in this field, and many others. And that's really important to understand how it works. And I'm going to show, for example, how it works step by step, based on our killer video Java example. Good. So, hey, I'm trying to scroll. Okay. So, if you open our killer video Java,
we do have a pull request. Okay, good to know.
Yeah, that's interesting.
I do have work to do now.
You see here a label build passing. What does that mean? It means there is a server behind this repo based on Travis CI. Oops, I want to open it in a new tab. Hey. And Travis CI is a continuous integration server which is free for open source projects. So that's great for us. If you want to run something proprietary, mostly probably you are going to pay them. But we run an open source project, so for us it's pretty easy. And we can see what we have with this repository, some builds. And I don't want to see current, but I want to see build history. So more. Okay, it doesn't show. Oh, yeah. Oh, finally it shows me more. And every row in this list is a build executed for us by Travis CI. So we explained to Travis CI how to build that. There are some success, there are some fails we have to fix. But the general idea, every time we change something before it's going to be merged to master branch, we have to assure what it works. And for example, I did a mistake. I fixed something related to YouTube. Don't remember what exactly, it was some time ago already. And here we have this job log, how it was executed and what was done. And we see some very familiar things, so we are going to use some secret environment variables to have password and user. And we build this thing, we pull the image, run some tests, build dependencies, and finally when it's done, what's very important, so yeah, okay, it's Java build, it's going to be very long. Oh, I'm already tired scrolling. Yeah, we are almost in the end. That's what I need. Okay, so in the end, we finished building our application. When we run dependencies, we will need, like here, you see docker compose -f docker compose.ci.yaml app. I'm running required dependencies. I don't need it to be open yet. So when they are loaded, I run the tests. And finally, then tests are done and all scenarios are executed. Everything is fine, is build success. Then I check if it was tagged release or not. I will explain it in a moment. And then I ignore it, so I will not push the image to a Docker hub because it was just a test to assure what it works. But if I go to previous list and I will find a version which was pushed, master, I need to have last release, and we didn't change it for a while already. Master. Hey, okay, yeah, here we go. Version 3.0.1. Now that's the most interesting thing I wanted to show you. Normal job run, you just seen. So we built the jar, we pull the dependencies, we run tests, we see how it goes. But here finally very important steps. As soon as build success, I check what's going on inside, and I will show you code what checks that. But in general, I check that's a Travis setup, so it's like Travis specific, but Travis is very widely used in the development world. So if I don't have a Travis tag variable, it means there is no git tag set on this commit. And therefore I go ignore non-tagged builds, Travis terminate, job is done. We are good. But as it was tagged build, it was 3.0.1, you've seen before, like releases. Where are my releases? As it was released 3.0.1's Env Vars connection configuration. Therefore, this build will do some extra job after success. We set tag to local build. So in the beginning, we build it like Docker build -t to set tag Travis commit, making this commit just an ID for the image I working that. And now I tag it as a killer video Java Travis tag. So I will use this 3.0.1. Then I log in locally to this Docker environment on a build server. and I do docker push killer video Java Travis stack. So I will push this killer video Java 301 to Docker Hub, and when I will be able to use it on production, for example. And finally, there's some Git mastery, so I cannot explain this thing in short, but the general idea behind that, if this image, if this tag, Docker Git tag, was also the latest one, like there are no 303, so by 301 is latest. Then I will also tag it as a latest and push it as a latest. A little bit of Git magic and Docker magic. So as a result, I will have Docker Java latest and Java 301 images both. That's it. So how it works and why it works in general? Answer is very simple. When we jump to the code, I have this file here called Travis YAML. Notice, Travis, I'm not advertising Travis. Travis is a great project. It really helps to support open source community. DataStax has no relation to Travis, except if we are using this project. And don't consider it as an advertisement. There are a lot of the build servers which may work better to you. Please, I'm personally a fan of Jenkins, but the builds for killer video we do with Travis, so I show Travis very simply. And this .travis.yaml file is everything what I need to do to build these on Travis. And all the required steps I explain it here. I should clean it up a little bit because it's overcomplicated. I'm used to read big files all the time.
But this one is a big one. It's a monster.
Yeah, the point is this one has some information what you don't really need to know, and I want to hide. For example, script is exactly the build server has to do to decide if it was succeed or not. But Travis fault is just a decoration to have this build nicely collapsed, and you can open some commands and hide some commands. Okay, this one don't open, this one opens, and so on. So Docker fault here is just a decoration, and you don't care about that so much. And I want to remove Travis fault for now. And again, Travis fault we don't need. Travis fault. So well, that's the script, and that's actually a pretty bad script. So I did some better scripts before in my life, and I will explain why I don't like it. So you will be able to avoid this mistake. At first, we do docker run, and we install all the required things. With Maven install, we run a Maven image, and we mount local folder to killer video Java, and we set work dir to killer video Java, and we do Maven install skipping tests, because now we only have to install the dependencies. Now, finally, we do a full Docker build. So dependencies are delivered, all the things I may need, I install it. Now I do Docker build for killer video Java local, using this jar file generated by Maven install.
Oh, here we do have a question about GitHub action, CI/CD. Did you use that? I always use Travis as well.
Yes,
so.
My answer is yes, and I'm going to show GitHub actions as well, much briefly. The general idea of every build server is exactly the same. You provide some configuration, how to build this thing. It tries to build this thing and shows green lamp if you are done. It shows red lamp if something is broken, except of the Jenkins, because Jenkins originally comes from Japan. So by default, it will show blue light as everything is fine. And every time I install Jenkins, first thing I do, I install plugin which will replace blue light with green light. Yep. Now I run DSE the DataStax Enterprise for tests. As those are integration tests, I will need real database. So I run DataStax Enterprise, and I run a special script to configure this file. And then that's the thing I don't like. Do not rely on time. Today your build server is idling and builds everything very quickly. Tomorrow your build server is busy and build everything's very slow. And this thing, sleep 180, is a bad thing. In general, don't do that. We wait here for sleep 180 because we simply didn't implement a health check if DSC config is executed or not. But in general, we don't have to wait for 3 minutes here. We have to check if job is done, and then we can proceed. When we start backend, and backend uses this killer video Java local, and we again sleep 180 for mostly the same reason. Shame on us. Hope one day I will have time to avoid that.
Shame on you. This is your fault.
Yeah, hope one day I will have time to rework that, but we always have more important tasks.
We teach.
Yeah, we do Docker workshops and so on.
Our time is it's dedicated to others.
Yeah, so in general, this sleep is just only to wait for this backend to start, and usually it starts much faster than 3 minutes. And finally, we just have to wait here till it's. I will do it later. Okay, maybe by next week I will show you better examples. We will see. Then I check if my backend is running. And here is some Linux magic you may be not familiar with. First one, I do docker compose using file docker compose CI YAML from this folder because we are in continuous integration CI mode. I exec command using running container backend, and the only thing I do is echo still alive. So just print something inside. And these double pipes shows a command OR. So if first command failed, when do command specified here? If first command failed, oh my god, it slides so slowly, but really, oh my god, move it. Here we go. So if this first command is failed for any reason, it means container is not running. Then I do this sequence. First I write backend is down, so build is failed anyway. I'm printing logs of all the services, so I have to understand what happens with DSC config and backend. And when I exit with exit code 1, it means what any non-zero exit code means failure. If you are a Linux guy, you know what I mean. If you aren't, very fine, but that's important to remember. On the build stage, any exit code non-equals to 0 will be considered as something when prompt build failed, red alert.
Oh, any batch you are developing should do the same, by the way. Exit code not 0 is an error, or
Yep, and finally, I run integration tests, killer video integration tests. That's a standalone project. Which will execute integration tests, and I run it as a part of a killer video Java default network, so it will be attached to same bridge network exactly as we discussed it last workshop talking about networks. And if every of those commands exits with exit code 0, it means what we are good. And these integration tests exit with exit code 0 if all the tests are good. Therefore, tests are done. And when we have the second specification here, so it was script. And now we have after success. After success and after failure, two different commands. First thing I do, if I check what kind of a build it was. If it was cron job, so scheduled build, just to check if all dependencies are still available, then I don't have to do anything. I put ignore nightly builds, Travis terminate. Job is over, we are good. Next, I check if this build was tagged. If it wasn't tagged, I say ignore non-tagged builds. There is no git tag, therefore I will push no image. Travis terminate. 0. We are done. All good. And finally, if both those conditions are fine, and that's not a cron job, and I have a tag, git tag, therefore I'm tagging the image I built in the beginning, this killer video Java Travis commit, yeah, this image I built here, you see -t Travis commit. I use commit ID as ID for the image. And we have this Docker tag. So this image will also have tag killer video Java Travis tag. So git tag. I log into Docker Hub and I push this one to the Docker Hub. So I will have 301. And if we go to hub.docker.com, oops, of course, it was a typo.
Fat finger.
Okay, could you please open it?
Docker Hub.
Yeah, Docker Hub sometimes pretty slow. And we go to killer video. And it was Java, so we go here Java. And we take text. Here we go, 301 was pushed by me, but it wasn't really. It was Travis who did all the job for me, and I really like Travis for doing my job. Thank you, Travis. So we just discussed this file. Anything to consider besides this story? After success is pretty clear. After failure is I want to see the logs. By default, I don't show all the logs of the dependencies and backend and Docker and DSC config because, well, they're going to be very huge in some cases, like all the tests are running, so logs are big, and if build is successful, I don't need to see them. But if build is failed, I need to see them to understand what went wrong. Then I'm using some environment variables, Docker, user, and pass. And you may say, like, you told us to not store your passwords like that, and that's very fine because it's not a password, it's a hashed key of the password. So it's not the password per se, but it's the ID of the variable stored deep inside Travis. And finally, notifications, Slack, room. There is again nothing to explain additionally. On build, I want to have notification in my Slack in a special channel, which is again secured, hashed, and stored in the secured variable like this. And few more things to add exactly regarding Travis. I say here in the services what I'm going to need Docker. So I will have Docker installed on the machine which will do this build. I will need to have sudo. Maybe it's not needed anymore, but before on Travis, if you wanted to run Docker, you needed sudo permissions.
Oh.
Yeah, maybe now it's not a thing anymore. And finally, language generic. When you work with Java and not containerized Java, you can simply say Java version, I don't know, whatever, 8. And it will try to guess how you would build this image, and it will do Maven install automatically. I again don't like this convention over configuration approach, because today it does Maven install with that settings, tomorrow it will change something and it will do Maven install with another set of settings, my build will be broken, I have to investigate it. In this way I say explicitly, language generic, it's for me to decide how I'm going to build this image. So it will not try to do Maven install second time. So that's how you do it with Travis. There is one more great thing recently happened with GitHub world. So, you know, GitHub was recently, not so recently, already bought by Microsoft.
Yes.
Well, that's not for us today to discuss, but what I want to cover, there is a great button happened to be called Actions. And I will find one repository of mine which uses these actions to show what you don't even need now Travis to build to do this kind of job. But let me find that. I'm trying to remember what was the last GitHub actions I used. And it was one of our give me a moment.
63 repo. You're a busy man.
Yeah, well. I remember what was the last time I've used that. So now you don't need any secondary projects to like Travis or Jenkins. You may run your also workflows with GitHub using GitHub Actions. Idea is exactly the same. You explain what you want to do in a special configuration file, and your build server will try to do it for you. So, okay, as you see, this one was not fixed for some time, but that doesn't really matter because for us, we discussed the good scenario when build is successful. We also have to discuss bad scenario, then it was failed. And let me see, I need the logs. Okay, in this case, yeah, that's a private repo. So let's take a look at different here. So anyway, it always goes to .github/workflows. And I have here build image YAML file, so also YAML format. And pretty small build file you can see. I name it Docker image CI. It will be executed on push. Jobs will consist only of the build. I will run it on Ubuntu latest virtual machine. And steps are very simple. First step will be to check out using actions checkout package. So that's just we'll do a git checkout on this particular version. And then second one will be to build Docker image. So I do Docker build specifying tags. And I log in to Docker to be able to push the image, otherwise Docker push will not work. And then I push those two, and that's it. That's a pretty simple script, so we don't have any tests here, but just Docker build. So, personally for me, I'm not so big fan of actions because Travis, for example, or moreover Jenkins, exist for much longer time. I find configuration file format much more convenient for Travis than on GitHub Actions. But GitHub Actions are working. They are using them. On another project I cannot show. Those are already some proprietary stuff. And it works pretty well for us. Yes, so I personally stick to Travis, but GitHub Actions are very useful as well. And well, for the complex scenarios, Jenkins is always number one. Whew. Some more things to mention. Yeah, so this example on the right, it's a complex scenario for the complex story. For easier situations, it works much easier. Then next very important thing, Git tag should match Docker tag, or vice versa. Docker tag should match Git tag. The great idea behind Git, it's transparency, it allows traceability, it allows you to see who did change, why this change was did, and if you do your Git workflow correctly, you even can trace any single line of code and any change set up to the ticket in Jira if you are using Jira or whatever you are using. And that's great because all the developers for many years were not able to use, like then Git was not a thing and version control was not a Git. Like Git is one of the best things in the software development world for real. And we use it to have this traceability from ticket to Git commit, to developer, to change set, and so on. But when the Docker comes, this rope, this string is broken because there is no direct connection between image and Git commit you did and it was built on. So I do very strongly recommend you to release your images using the Git tag they were built in, or at least using branch. If you aren't using Git tags, use it with that, and commit ID, for example. It's also a good story to use commit ID. If you are releasing using Git tag 1.12.3, your image should be released as also 1.12.3. It keeps this traceability, and that's really important, and that's a great practice you do want to follow.
Question just, do you like Jenkins?
Oh! So, I like Jenkins, but many people think it's a Stockholm syndrome. Like, you know, when hostage start to support terrorists. That's a pretty well-known psychological syndrome. And yes, I like Jenkins, maybe too much. There is a lot of blood and pain behind this story, but yes, I like Jenkins. For complex scenarios, it's definitely the best tool from my point of view. Getting back to tags, if we have Git tag version 2.0 releasing, and due to some reasons we want already to use it on staging, but we don't want it to sneak to production. Very traditional way here, and very good way, is to use release candidates. Release candidates is a thing when you can release a version using tag docker tag 20-rc1, release candidate 1, release candidate 2, release candidate 3, as much as you need, and then it's all done. You can release it as just 2.0, having your images prepared for everything and your staging already using release candidates, and it will be easier to switch to a newer image release, well, depending on your environment. Now, that's about testing thing. When you work with images, testing, from my point of view, gets much easier if you utilize it right. And the most underestimated kind of service is a simple smoke testing, and you absolutely always must have it because it's very easy to implement, and it really opens and covers a lot of issues. So what's the minimum, what's the smallest thing you expect from the Docker, from a running Docker image? Usually in the end, when it starts, it at least has to open a port to support external connections. There are some cases you don't need that, but we speak about the simple scenarios. Idea of a smoke testing is very simple. Just plug it in a power socket. If it smokes, something is wrong. Simple as that, and people start to think, oh, that's too simple, I need to have more advanced things, and then they are busy with higher priority tasks, and then they have no testing at all. So what's good in smoke testing, you can set it up within 1 hour, and usually you are able to find 1 hour for quality assurance. Of course, you should find much more time, but that's already something, and a lot of people forget about that, but that's important. Doesn't matter how complicated your unit tests are running inside the container. If wrong port is open, your application will be not reachable. So that's very important to just start it, wait if it listens on port, expected port, after some seconds. Expected timeout time. Fail build if it doesn't, and it's really easy to test. So that's great approach, and it really helps to find a lot of possible problems. Functional testing, and that's my favorite type of working with containers. What's the container, and what's the image, and what's the service as it is? It's kind of a black box. I give there some input data, I expect some answer. If I have a service which sums numbers, like it expects two numbers and dispatch the result, the sum of those numbers. I run the service. I send 2 and 2. I receive 4. And basically that's it. It's a black box. I don't care what's in. That's not a unit testing, because from my point of view, functional, smoke, and next level we will speak in a second, are much more important than unit testing. That's a very not a simple thing. Which one is better? Mostly probably you are going to have all of them, but in some cases and functional testing works much better, as we have this isolated container which is easier to test with the tools we are using for functional testing. So how it works: I have specifications explaining what exactly going inside my container. Well, not sorry, that's wrong. No, I have a specification which results my container should give, because it's a black box. I don't specify what happens inside. It's a secret. It doesn't matter what's a kind of a dark magic there, if it runs with Java or I don't know, assembly or anything else. I don't care. It's a black box. I don't care about the behavior. I care about the result. And I give this input data, I receive the result, and I compare expected in the specifications result to the actual result. And in general, that all goes to API testing. If you have your API using HTTPS and REST, okay. If you have gRPC, okay. If you have GraphQL, okay, that all doesn't matter. The final duty of running application is to dispatch some response in the very end. And whatever API we are using, functional testing should cover this API and assure if we give 2 and 2, we have to receive 4. Functional testing bit more complex than unit testing, because mostly probably you're going to have some dependencies running alongside. Like for example, I told you for our Java backend, for testing we need to have DataStax Enterprise running behind. So in this case, it delivers some network dependency, which is bad. In general, we are trying to avoid network dependencies during testing, because it leads to problems like, first of all, it works slower and you want your builds to run fast, and second of all, it's may provide a lot of false positives. So test was broken, build was broken because of a network issue, and it's a false positive because technically your code is great. It was just a local problem on a build server. But here is a trick. As long as it's actually Docker network, Docker software defined network, and everything runs on a single machine, amount of false positives due to networking issues are actually about 0. And it still gives me a very good way. So the specification we are talking about, they aren't only for testing, but they also very good for acceptance tests. So your application dispatches exactly the expected thing we need to have as an answer. It means it's not only on the build time test, but in general for the acceptance test. With functional testing like that, with API testing like that, you can very easy go with test-driven development, and that's a very great approach when you first explain every response to every question you are going to ask service, and after that you start to develop the service. And test-driven development is very well implemented with API testing, especially for microservices. That's just great. So how to implement functional testing? Well, it should be a part of a continuous integration build, of course, but how exactly? It's a very long story, because we have very different languages and very different frameworks. And again, if you would try to cover all of them, they are going to be in big troubles. So Cedric, speaking of functional testing, what you would say regarding Java world?
So first, I think about frameworks like Cucumber. That's really now following a scenario. So it's not only sending data, expecting data. It's really having a full workflow, step 1, step 2, step 3. And the success of the test is really if all the 3 steps are correct. And most of the time, each step are correlated one to each other.
Yep. Yep. So Cucumber is a great thing. I like it a lot. It's more about the next step. We are going to discuss just one next slide. And about functional, well, it's heavy depending, and API testing, it's heavy depends on what exactly do you develop. But good thing here, you see for, and I show you for this testing of Java, for test of this Java thing, I'm used DSC, Java. Where was it? Okay, I will open it again. Java, here we go. To test this Java application, I'm using killer video integration tests image. And it will be the same for the Python backend of our application, which delivers the same API as it's a reference application. It delivers and it works perfectly with the Node.js application as well, because it's isolated from the service you are developing. It just makes API calls and compares the result. In our case, with killer video, we are using gRPC, and that's just a gRPC for testing set, which makes gRPC calls and compares the results. If you want to see how it's implemented, it's great, because here we go with in killer video integration tests for killer video server, and they work with multiple backends written in different languages, and it doesn't care, because the main job here is to just run API calls and so on. But we have to move on. So few last things. Okay, here we go. And finally, end-to-end testing. End-to-end testing is easier to speak about the frameworks in this case, because usually now we speak about the systems, those have web interface, and therefore there is some JavaScript in the very end working together. End-to-end testing is the slowest and the most demanding, but also very, very required and very positive for your application stability and quality assurance purposes, because it requires all the backend running with the databases, backend services, and so on and so forth. And therefore, it's not going to be quick. But as a final result, you know what? None of your users, none of your customers cares about Java, Python, backend, gRPC, databases, and all other shit. All your clients, guests wants to see is some kittens on YouTube, and I don't know, send a message to a friend, congratulate grandmother with her birthday, and so on. And no one cares about languages and databases. Sorry. So end-to-end testing is one of the most important testing things, because this kind of integration test makes all your systems working together and showing how it works. Again, with again with Docker, it's very easy, because everything is explained how to run in Docker Compose YAML file. And one thing is left is to run test suite alongside running application with Docker Compose, and see if it's greens in the end. And again, I've seen so many situations. People, end-to-end tests are complex. End-to-end tests are heavy. End-to-end tests slow. And I have no time to implement that. We have some more important tasks to do right now, and we will do it, of course, later. I tell here very, very seriously. To test your system with Protractor, for example, I'm speaking of Protractor not because it's best, although it's pretty good, but just because I have the highest experience with Protractor, so I can speak surely about that. You can describe tests covering your three main use cases, like user logins, user opens profile page, user opens that page, without any complex scenario. It's already will catch half of your infrastructure problems, then they come, and they will come. That's not a question anymore. That's just exact rule. So shit will happen. Do we want it or not? Again, I'm not advertising Protractor, so there are some more technologies. I definitely heard a lot of good words about Cypress and Test Cafe, but there are more of them. So end-to-end testing is a thing you can easily implement today. Just put 2 hours on that and you will have simple end-to-end test implemented already, which works great, and that must be a part of your continuous integration and delivery system. But this workshop was about Docker, not about CI/CD so much. So let's proceed to assignment. And
all right,
I have a thing to say. Our last assignment, week 3, got only 2 submissions. And I really want this list to be longer. So, and actually they were submitted very last day, so I didn't have time to review it already. Sorry, I will do it later on this week. So, again, Docker learning path, and I wait for more submissions. And I kindly ask Andrea and Renato, you also have to watch each other's code and learn something from that and maybe improve some suggestions. But anyway, week 3 assignment. We proceed to work with week 2 and we improve that. Hey, Google Slides, would you please? Okay, it's loading. Good. So, week 3 assignment. We are using week 2 task, first task as a first step. When we proceed to improve that following this week's steps, we have to take care of the environment variables. So when you run it on production environment, it will have password stored on the environment specific storage, not in your source code. When we go with GitHub Actions or Travis build, whatever you prefer, both will work well. Fine. And at this build, that's very essential to add a very simple test. Smoke test will be completely enough. If you have unit tests, that's great, but take a look. Unit test and smoke test are covering very different situations. Your use case, unit tests may succeed, but port will be closed and your container is not operational in the end. In the final end when you are trying to use that. So don't think I have unit test, I don't need smoke test. You do. Unit tests are to test the code. And smoke test is to test the container, and those are different entities. If you didn't start it yet, please use our week 2 samples for the inspiration. There are at least 2 examples, and you may take a look at the killer video as well. Then you are done exactly at the last week. Publish your code on GitHub in your repository and create a new issue at DataStax dev Docker learning path issues. Take an issue from the list. We already have 2 submissions, so you can go and watch them and write your suggestions, watch what people did differently, what you would do, or there are any place for improvements, or maybe you can learn something from them. That's always great to see how our works. Write the feedback. And as you did that, please ask us to review your assignment publicly if you want. Those 2 assignments were submitted just too short time for today, so we didn't have time to prepare for that, but we will do it next week, exactly speaking about best practices and therefore not so best practices. And that's it. We are done. And people are speaking about the Selenium in chat regarding end-to-end tests. And I would a little bit disagree because, well, Selenium, as it is, will do end-to-end test, but it also includes the real interaction with front end. So it tests even more. It also tests like button position, if you can push this button, or it's blocked by some overlay, and so on and so forth. For me, to maintain Selenium tests, Selenium is great, and Selenium tests are great, but maintaining Selenium tests from my point of view, is harder than maintaining protractor tests. And as I want to have results fast and cheap, Selenium covers more and also very important. But if you want to start with something, protractor may be easier place to start. Although Selenium is great, and I do recommend to take a look at the Selenium also, it may be better for you than protractor or Cypress. Good. And basically that was it. That was Cedric, that was Alex, and third week is done for you, and now that's the assignment time.
Yeah, not a lot of questions today, but good question anyway. Thank you very much for being with us. We are week 3 on 5 week total now because we added Kubernetes assignment in 2 weeks.
Yep. So thank you so much. And I think we are done for today. And don't forget, if you want to communicate and ask any questions or whatever, join our Discord chat. You don't have to install Discord. You can use it completely in browser. And we will be glad to answer your questions then.
Yeah, or as usual, community.datastax.com. We answer all the questions there as well.
Yep. Okay, thank you so much. Thank you, Cedric.
Thank you, Alex.